The only other concept we'd like to look at would be the concept of work. Work is just equal to force times displacement times the cosine of the angle. And the angle here is whatever angle is formed between the force and the displacement. And I'll show an example of this in a second. The second definition of work is just a change in energy. If you think back to the concepts we discussed previously, if energy is added or taken away from a system, it seems to magically appear or disappear, then work has been performed. So work is either a change in energy or a force that acts over a given displacement. So let's look at two examples here. I have the same force in both examples, 10 newtons, and the object is moved 10 meters in both examples as a result. In my first example, the force and the displacement are completely parallel. They both act in the same exact direction. In my second example, I have an angle between these two. While the displacement is to the right, the force is acting upwards. There is an angle of 35 degrees between my displacement and my force. So if we analyze both of these, in the first case, my force is 10, my displacement is also 10. The angle between them is 0. If I kind of moved this displacement vector up and overlaid it on top of this force vector, you notice there is no angle between those two, so cosine of 0. When I calculate that, I find that 100 joules of work was performed on this box. It gained 100 joules of energy. You hopefully realize if I pull on this box with a force, it will begin to move. So in this case, I would gain 100 joules of kinetic energy. If I look at this example, same equation, the only difference, because I have a 35-degree angle between the displacement and the force, I just plug in 35 for theta, and I wind up getting 81.92 joules. It's slightly less because I don't have as much force pulling to the right. In this example, all the force pulled to the right. In this example, I had some pulling to the right, but some of that was also used to try and pull the object upward. So a little bit less force acting to the right, so a little bit less work is performed. So the main concept to realize here is this angle is just the angle between your force and your displacement. In an example like this, it's 0. In an example where the force acts one way but the displacement is in the opposite direction, that would be 180 degrees. Anything in between would be the given angle. Don't forget that work is not only this, but it is also equal to a change in energy. So you could also, based on what you're given, calculate it in another method. So here we have a box that is sliding before with some given information, and it comes to rest. So friction brings this box to rest. If we take a look, I have no energy before except for kinetic because I have no height and no elastic compression. So 1/2 the mass times the velocity squared gives me 12.5 joules. Afterwards, it has no energy, it has 0. You should immediately realize, wait a minute, this is impossible unless work occurred. So I did have a change in energy. I lost 12.5 joules, and that will be the work that was performed. So I can either calculate it using the force and the displacement, as well as the angle between them, or I can simply calculate the change in energy from before and after. Either one of those will give me a value for work. And work, as you can see, since it's just a change in energy, is also measured in joules.